Hello and welcome to Live Coding with Gerph. It is a new project today. So last week we finished the project to do the system variables module. It's functional and able to be used by people if they wish to, or updated or whatever. It can be. It's actually pretty decent, and it's got testing in it now. So next project is Window Manager Templates. So let's just try and give a bit of background for anybody joining here. This live coding is where I take a small project, hopefully small project, some of them have been quite long, and try to produce some code that will actually function and be useful, and more specifically is working towards RISC-64 functionality. So RISC-64 is a new iteration of RISC-OS. It's basically RISC-OS 32-bit or 26-bit or Arthur in some cases, revamped to run on ARC64 architecture, and that's the plan. I've set out this in a number of presentations, and the goal is to have something that is useful. But to have something useful, we have to start building out all of the technologies that are needed within that. Most of RISC-OS is assembler, so we have to rewrite those sections. So if we have a look over here, this is the main RISC-OS 64 status page. And this describes what is being done at any given time. So the current status goes through all of the different components and where things are up to. So, for example, we worked on system variables. That was an assembler module previously, and now its testing has been automated. So it's come along quite a long way, which is very cool. And today, let's scroll down here. Actually, pretty easier. So this is the full status. Today we're going to work on the Window Manager templates, as I've mentioned. The way that this has been planned is described in planned work, and you can read through this in your own time if you're at all interested. But essentially, it's broken down into a number of phases. It's also sort of broken down to stacks. So we've got different stacks for things: the audio stack, compatibility, core, desktop, filing systems, and so on. So you can look at it that way around if you wish. But phase one is the most basic of things. It's where we're up to right now. We're at 61% complete. Not a huge amount, but yeah, we're getting somewhere. And the goal is to try and get, in phase one, all of these components to this functional level. So there is a description of how this works. So the terminology is described here, and there's different functionalities going from investigation through having a prototype, having something that's built, but we don't know if it's working or not, getting some internals up and running, but not wired up to anything, and then making it functional. Functional is the real goal for a lot of this work. There may be that we have to move it on to complete, which is a little bit more involved. So that will actually include a bunch of extra features like internationalization and maybe additional functions that are not used quite so often. So that's the sort of structure that we use for the functionality. Oops, go back a page. So go back to the phase one details. And the goal of phase one of the development is really quite simple. It's basically to show people, community, developers, that the work is happening, that there is something going on, and that there is an actual process here. Additionally, by the fact that it's split into phases and each of the components is building upon one another, we can see that there are a lot more structure to what's being done. You might say there's a bit of a plan. I mean, it is described as planned work, but this is very loose. But it is a large project, so it needs to be structured in a reasonable way. So that's those are the sections, and this is the diagram that shows what has been done and what is intended to be done for phase one. So here we go. We've got, for example, if we look at system vars, which is what we did, we've got all of it complete all the way up to internals, which is what it was expected to be. It's actually complete all the way up to automated, but we're only showing the ones that are actually present in this part. And if we have a look at Wimp Templates, we hope to get it all the way to internals in this phase. So that's what this project will try and do. We can go and have a look at what's involved in the templates by clicking on the link. And we have an additional table here that shows in phase 1, we're expected to get it all the way up to internals. And then in phase 4, we make it functional. And the reason that that's in phase 4 is because phase 4 is when we start accumulating all of the components that go into the window manager. But getting the templates done early, because it's not dependent on anything, makes things a little bit easier. It means we've actually got some progress. So, yeah, here we go. We summarize what's there. We say we can open stuff, we can load stuff, we can close stuff. And this is what the component's going to do. I've also broken down the functionality into a set of particular operations that need to be done. Not all of which are simple. Some will be a little bit more involved. And then there's a breakdown of what SWIs need to be implemented and what additional calls are needed. So not a lot, really. I mean, we'll need to open files. Probably I should have mentioned files, but I think files are pretty much fundamental to the system. Allocating memory and things like that is all pretty fundamental. So that is what we're aiming to do today. And we won't get all of this done. We won't get all the way to internals, but we will get a reasonable way, I'm hoping. So, should we start? First thing to do is to create a new project. So, create a new directory called Riscos Wimp Templates. Riscos Wimp Templates. Okay, and then let us open it. Here we are. So this is our new folder that's got our bits in it, of which there is nothing. So initialize git gives us nothing in there, and then we'll set up a project. Come on, see if I can type. Oh dear, not boding well for today. Riscos project create. No, I don't want PNetGB. What are the ones we got in here? So I want a command line tool because I don't want the library tool. Is it library? I don't know how I do it. Let's have a look. Command. It's called command. That's why. I could have just pressed return. It would have given me an error message. Name is Wimp Templates. So the way I'm going to build this is build an application first, a simple command line tool that can load and save, not load and save, load and display information about templates. And once we've got that working, we can start thinking about things that are a little bit more involved, and we can actually test things. But if we do it in a simple application, a simple command line tool, we can get a long way through this without having to worry about anything else. So that's what we're going to do. Create a new project, and so that's built as a makefile. Oh, I probably wanted to actually create a skeleton as well, so that I've actually got something to work with. Here we go, create a skeleton for it. Right, we've now got a c/main. Yeah, if we go up here, yeah, I have so many files open, it doesn't auto refresh. Yeah, so there we go, there's our main file. So let's start this out and let us build it just to show that we can. Riscos ammo, build it, thank you very much. Built, and we'll run it. Pyrodev common gos. Here we go. Hello, Dave. You're slacking, Dave. I mean, Alan was here like 10 minutes before we started, I think. And hello to anybody else as well. Sorry, if you're chatting, that's fine. If you're not chatting, that's also fine. If you want to say anything and like suggest things or ask why things are being done particular ways, please feel free. As I say, I've described at the very beginning what we're trying to achieve here. So hopefully that will make sense. So we have a program. Doesn't do anything, but we have a program. So have a look now. We've got those files. Yeah, so I'm still in Riscos. Yeah, let's jump out of Riscos. It kind of amusing that Riscos actually also handles the Git commands as well, which is quite cool. What was I going to do? Oh yeah, I was going to do Riscos project. Let's create the CI file, not the CI files, the Git control file. So we hide the O32 and AF32. Hello, Shantanu. Yes, Riscos exists. It was the original version of an operating system for ARM. Acorn developed the ARM chip back in the early 90s, late 1980s, I think it was been designed for. Acorn produced something called Arthur, which was the very, very first operating system. And then Riscos came along afterwards. It still exists, still running for people. People are doing stuff, and I'm crazy enough to be one of them. So, yes, we're going to go and build for that. Let's see what else we got. Oh, I didn't mean status, I mean add. Silly boy. There we go. And we'll add the git ignore and git attributes as well. Right. There we are. We have some very simple files. We also want to make sure that this gets tested. So let us do the testing part as well. So create CI. We'll also create some files for CI purposes. So add the row build YAML and the GitHub directory. We don't need the GitLab one because we're not building on GitLab, so we'll just leave that for now. And then we'll commit. So, initial implementation of the Riscos Wimp templates does nothing. But one thing we will get out of it will be a build. So I've just remembered. So let's go and create a repository for this because we're going to need something in GitHub. So if we go back over here, hello Acorn and Riscos, whoever you are. Very generic term. Right, so GitHub, please. I didn't need to enter it into Google, did I? Right, so here's me on GitHub. We're going to create a new repository called Riscos Wimp Templates, template management for the Riscos window manager. It's public, and I don't want to add anything to this. Please create repository. There we are. I now need to go and copy this into here. Git remote add origin, that repository, and then we push it. And if we are lucky, and I've done it right, I'm going to come over here and we should see, come on, there we go, there's an action running and it's starting to build. And hopefully this will actually, like, the very first thing we're doing, very first thing is making sure that it will build. Here's its building, and then there we go. That seems to have built. I'm quite happy with that. Yeah, it's built. It tried to build some like resources and things. Don't care about that, but it hasn't failed anyway. Okay, so that's all doing quite well. One thing I did notice there, that took 15 seconds to build, long time. So let us quickly modify the definition of the build file, which is rowbuild.yaml, so that it builds quickly. You can do that by saying alias amu. Whenever you run the amu command, instead run host amu, and that will make it build faster. Commit -a. Improve build speed Probably not emulating. Native on the build service. So there we go. And we'll push that again and just check that that has also worked. So last time the whole thing took 21 seconds. This time, hopefully, be a bit quicker. Click on there to see it. It's done. 9 seconds. 9 seconds it took. That's not too tall. 13 in total. That includes all the setup time as well. So not too bad. But obviously, I've done nothing. There is no code here that actually is useful. Now I actually have to start writing something. Ah, dear me. And as you know, that's the harder bit, because I've just templated things. Normally, what I do to make this happen is I start out by looking at the documentation. So here's an old page that I've got on the PRMs. Let's just drop that over there. Right, so find window manager. There he is, window manager. And obviously there's a lot of stuff in here. So templates. Really, I should be using the documentation we've built, but I haven't got round to it. So this is the documentation about template files, and it talks about a whole load of things about how they work and what they can do. Templates have a number of different features to them, which we have documented in here. This is the one. So we can open files, we can handle wildcards, we can read the template, we can size the template, we can enumerate them. I'm pretty sure enumeration is a part of it. Acon and Riskos asked, what is Pyromaniac based off source-wise? I'm not sure what direction you're coming from there, but the source is all in Python, and there are parts of it that are the emulation parts. So all of Riskos Pyromaniac is Python. There is no there is a tiny bit of ARM assembler because certain operations are difficult to do in Unicorn, which is the emulation environment. So there is some assembler in Pyromaniac, which is basically move a couple of system registers around. Early versions of Unicorn didn't support them. So that's what it's based on. If you mean what sort of operating system it targets, it tries to build against, it targets Riskos, full stop. Riskos is the canonical version of Riskos that is everything that is not incompatible with any other version. So that means I'm not using the things that were intentionally introduced that broke other canonical things. That means that certain Riskos 5 features aren't supported and certain Riskos select features aren't supported. Which is it closer to? Arthur? So let's talk Riskos Pyromaniac for a moment. PyroDev list modules. So modules that are supported, there are a number. We've got 65 modules in here. Let's make this big. So we provide a whole bunch of different features in this, some of which are quite late, URI for example, some of which are very late, video teletext, that's a select feature, some of which are new because nobody else is using them, the fan driver. I'm not sure, I think maybe Chris has done some stuff with fan driver. GPIO for example never existed in Riskos Select, Riskos 4, Riskos 5 has it. Image file render is a select thing, so it's basically trying to do whatever is the canonical version of Riskos. It has no particular preference other than it not being compatible. So where Riskos 5 has deviated from previously documented and implemented environments, Riskos 5 lose out. Vice versa, where Riskos Select has implemented something that was done in Riskos 5, same thing happens. So it is the most generic version, but remember that most of this stuff isn't actually important because most of the system hasn't changed. It has not changed a lot since Riskos since Arthur. So the target is whatever makes the most sense. The whole point of Risk-Os Pyromaniac is to be able to test things out. So if you want to turn on, is this bridging the gap or bridging the gap between what? I mean, the whole purpose of Pyromaniac is to be a development environment. It's a development and testing environment to trial, to work things out, to make things easy. The whole reason for Pyromaniac existing in the first place is that Risk-Os itself is, let's say, pretty bloody awful at providing any sort of testing and development environment. It really is quite terrible. So Risk-Os Pyromaniac allows you to do operations repeatably, to be able to test them, and if you want to see things working, you can do stuff much more detailed than you ever could with Risk-Os 4, Risk-Os 5, Risk-Os Select, obviously Arthur, Risk-Os 2, Risk-Os 3. So let us have an example. So let us yes. So Risk-Os PyroDev common. So there's PyroDev is a shortcut command that I use. It actually invokes a number of different things. It sets up C library and others. So if I just do an bash -x PyroDev, so this will just print out what it's trying to do. Oh, all right, a bit more than nothing. So this invokes the pyro command, which is Pyromaniac, load all the internal modules, use a configuration file that we've created to do things. And that configuration file contains this information up here. We've got load the basic module, load the obey module, load the clib, and load the FP emulator, because those are all in ARM assembler. They're all provided externally. And with that environment, we can then basically do things. So if I go into PyroDev here and I want to run the command, let us say af32.wimp templates. Templates during typing. So this runs the commands that we just built. There we are. But we can also say, turn on some debug. I want to see all the filing system operations. But actually I can't remember all the filing system operations. So let's just quickly remember. So list debug. So these are all the debug switches that we can have, all the different options. There's a lot of them, and I can't remember what the filing system ones are. So let's spin up to here. So we've got OS file and OS FS control is probably a good intro area. So if we try and go back, debug OS file and OS FS control. So now, as the system starts up, we get to see that there was an OS FS control command run that started Wimp Templates. And that's it. There was nothing else that happened, at least on the OS file interface. We can also do other things like listing service calls. Where's services? S. Services, here we go. So yeah, we just turn on services. So if I do the same thing there with services as well, we can see all of the services that happen during startup and start application call, and the service call that said new application, and then the fact that the system was shutting down. So lots of things happen, lots of things going on in there. We can also turn on specific debug. So if I say boot debug, so I only want to debug after the system has started up. So that's all the way up to this point here where reset happens. I only want to turn it on there. And then I want to turn on tracing. So if I do tracing there, this will now list every instruction that's executed. So that's an initialization code. I think that's 0 initialization. Yeah, it looks like it's 0 initialization there. No, it was never intended as a 64-bit solution, and I have explained to Rule that that is not the case. It is a development tool. So yeah, I will not give any comments on the motivations or intentions of Risk-Os Open, because almost certainly that is a something I'm likely to misinterpret. So I won't give any comments on why they're doing that. You would have to ask them that. If you want more information on the specifics of what and why Riscos Pyromaniac is useful, I produced a document describing what Riscos Pyromaniac was and why it's useful to the Riscos world as part of my claim of the part of the bounties. As we're talking, this is still running that code. It's decoding every single instruction and all the registers and everything that's gone on. So that's a bit heavyweight. But you can see everything. You can see everything that goes on, and you can tell all of the components of it. That was probably not the most sensible of of things. I have a larger presentation that's coming up in, oh my gosh, it's on the 17th and I've barely started, which contains the we're looking to contain a broader strokes on what Riscos Pyromaniac is and how the project to move to 64-bit is functioning. So yeah, you saw there was a lot of output on that, and that was pretty blooming boring. But you can also see in here that there are registers, functions being entered. You can trace what's going on. You can also do special things like config trace dot trace point, I think it is. I want to trace anytime we hit the main function. So this is doing the same thing, but just doing that. Aiken Riscos says, appreciates the work on Select and use it today. Your contribution is greatly appreciated. Well, I'm glad. As I say, I'm continuing to try and make sure that things are developing and moving forwards in a different way. And this was the output we got. So when I said to trace main, it's told me about the entry to that function and said these were the registers on entry, these are locations, this is the function that was entered, and these are the parameters that it was given. It hasn't got the parameters to main because we're just entering it. So there you go. That's the sort of basis for this, what is going on. And the point of like trying to be as agnostic to the operating system version as possible is that you can try things out in different ways. I mean, there's, I'm just trying to think of a good example here. Help config less. So I think there's something here that's described as, is something in Riscos 5? So here you can change how the internet module manipulates things. So normally on Riscos Select, the error numbers were returned based at 0. On Riscos 5 and with the new Internet 7 that's from Riscos Developments, all of the error numbers are based at this address. And so you can reconfigure the system so that it returns either old style or new style. And that can allow you to find incompatibilities between different parts of the system. And if you know that's the problem, then that's good. Otherwise, it's just another switch you can use. There's also other things that are not operating system specific. So there's a file. Oh yeah, it was in the middle of them doing things. So there's a file system. If I have a file system dot. Sorry, capital F file system dot. There we go. So in Riscos itself, close 0 would normally close all files, but it can be. Oh, I left my ring in the bathroom. Thank you very much. That's what happens when you're rushing to get things done. You forget important things. So instead of closing all the files, which is frustrating, you can make it generate errors, or you can just ignore the operation, and that can help you to find bugs in things or identify issues. Similarly, there's been a constant problem with filing system enumeration. So with filing system enumeration, the normal thing to do is you call and say, I want to start enumerating. Here's a file back. Your next reference number is this number. here's the reference number, give me the next one after that. And that's the way you would normally enumerate things, or you get back a number of files or whatever. But that number that you get back isn't necessarily 0, 1, 2, 3, 4, 5, 6, 7. It could be many of them. And so Riscos Pyromaniac can allow you to configure different things and different ways of doing it to test your program. That is absolutely fine. So Acorn Riscos said, sorry, I didn't mean to hijack your stream, but the explanation is great. Thank you. So yeah, I will get carried away on describing things, and I probably shouldn't. Let us move back to the original process. But yeah, I'm always happy to provide information on what's going on, like Shantanu. Oh, it's a hard name for me to pronounce. I'm very sorry if I've mispronounced it. It says, just stumbled onto this and was smart. I wish I was smart enough to understand this at this point. You understood that you're working on really low level code to create some OS level tools. That is correct, yes. I'm trying to create tools so that we can bring the operating system to a new level. I can also test high level things. So the tooling that I built can also run full games. I recently 2 years ago, ported Heretic and Hexen, which are 3D first-person shooter games. And those are actually tested by running through the emulation as well. So lots of things going on with this. But yeah, I'm very, very happy to explain things. One of the things that's difficult about these streams is that not everybody has the same level of understanding of things. And sometimes I just go off on random tangents and lose people. So I absolutely love having the engagement from the community to be able to bring things forwards and try and communicate what's going on, or clear up mistakes, or learn from people. So Dave, a lot of the time, Dave Thomas on here, commonly comments on things and asks me why I've done something some way, and then I have to go and rewrite things because I've done it wrong. But I can talk quite a bit, so let's try to get somewhere with it. What was I doing before that? Let's just scroll up. Oh, we've got lots of output here, didn't we? Oh yes, because I did a trace, so that's going to be lost to the history. Clear the window. All right. So I was saying, these are the operations we're trying to do, and we need a way of doing that. Now, the window manager's template handling is all written in assembler. And I am not going to look at it. The best way to implement anything in Riscos, in my view, is to work from the documentation, not the source code of modules and things, and implement to what the documentation says. And then you can find out where the issues are, and hopefully you can update the documentation as well. So far we've done nothing. We've written a tool that just prints out an error, a syntax message, and that's it. So we're going to need to start putting some bits together. And what we're going to need for that, we're going to need something that can actually read a file name. So let's just start changing this so we've got something that can read a file. So const char star file name. Oh, actually, that line I just deleted. Yeah, I probably want to keep it. Syntax Wimp Templates. That's right. File name. So this is, we're going to just process a file, and that's all we're going to do. If argc is less than 2. Oops, I'm doing well on typing today. Exit 1. Right, there we go. And then here, right, file name equals argv bracket 1. So what we're going to have is some functions. So let's have them called templates open. So there are three major swipes here. There's open, close, and load. So let us implement those just as if we're doing it in C, with no reference to how they're actually what they need to do. We're just going to provide some very simple functions, and what we'll do is we'll provide a handle that the templates can be opened with. So type-def struct Wimp template, no, open template this will be, won't it? An open template, open template. So what things do a template have? They're going to have a file handle, and do we need to know the file name? We could potentially use the file name. No, I won't. So for now, let's just start out with that. We've got an open template, fair enough. So open template T is what we return. So files.fh, fh equals fopen. We're going to open the file, and template files are binary files, so we need to read them in binary. If the file handle could not open, nope, return a null, failed. So now let's start thinking about documenting it, because we're getting some of the design. So open a template file backend for open template. So if you know the window manager at all, you'll be seeing that there's something I'm doing here that's different, and that is I'm returning a file handle. And that's interesting because we don't actually do that in the Wimp template, Wimp open template. You can only ever have one open template at a time. But why should we be restricted to that? Why should we have any sort of restriction on that? So let's implement it as if we're going to be quite nice and flexible. Pointer to a template object, an open template object, or null if we failed. Right, so we're going to need to have an open template I'll call it opt. I have a thing about calling them, having variables that have got shortish names that try to describe what they are. Yes, I could make them longer and the like, and almost certainly somebody can go through this with some refactoring tool and do that. But as I'm typing it by hand, I will do that. One of the things you will notice is that I don't use the any of the language servers or any other help on this, any AI help or whatever. I almost certainly could, but I do like to write it myself. Yes, I'm a little bit old school. It would be genuinely interesting to see if we could write a function that would do this. But on the other hand, I don't think that, I don't know. It would be interesting. It would be quite interesting to see what happens with that. But I'm not going to do it right now. I'm going to write some code anyway, because I just don't want to get bogged down. I might have a little digression later, and we might try that. If OT equals null, actually what we should do is we should do the opening of the file second, because opening the file might have side effects. So we'll allocate the memory first. If we allocate the memory first, then we've got to return free whatever memory we had. We failed, return null. There we go. Right, and now if we open the file, we've got that. Right, and then we can return the handle. Okay. Now, one of the things that I like to do in these is to have debug, because sometimes it's just handy to be able to turn some debug on and have stuff come out. So if def debug, this is my standard. Oh, thank you very much. Ian's just pointed out that I've done nothing with my with my handle, so it won't be any use. So thank you very much. This is Let me try and resize these things because I don't need the terminal just yet, but I do need some of this. Come on, move it. Come on. Thank you. Got my kittens under, well, my kittens, my parents' kittens. Right. Yes. So I was doing the debug, wasn't I? If one printf else. This is just the standard way that I do this. And printf debugging is still a valid way of doing things. I probably would like to have some better way of doing it, but I haven't got around to it. There's a lot of tooling I would like to write. So what we can do here is say templates open, failed to open file. Let's say dprintf. Opened template file. There we go. Some quotes around that, shall we? So it's nice and tidy. Okay, so there we go. I've got a file name now, and then we can actually, in here, we can do template. Sorry, no, open template. Open template. Alt equals templates. Open file name. If we fail to open, so I'm going to implement a reader for a file format called templates under Riscos. If you're interested in the details, I should have posted this, shouldn't I? So this is the what is being implemented. Oops. This is the what's being implemented. At the top of this page, there's a link to the reference manual that describes the whole of the system. I'm only implementing the templates part of it. So it's basically reading a file format and decoding it into binary is what we're aiming to do here. But we're doing it from the very beginning, just very simply producing some code that will read files at the moment, and failing for that matter. So what I'm going to do is I'm going to run the build in here, and we'll get no effect in integer context. There's no printfs there. Oh dear, yeah. I accidentally hash defined if statements. Let's try building that again. Better, right, okay, so that's built. So now we can try running it. Paradev common, that's the command. And if we run it with no arguments, it should print out an error message saying what the syntax is. Oh, I haven't got any templates. Let's grab a template file. Pyromaniac, test code, test data, templates. Actually, why don't I copy the whole lot? Let's have a look. So in there we've got this mucda test data and templates. And then if we copy all the templates that are in there, all those templates into test data templates. Oh, there we go. Add test data. Okay, so this won't do anything useful, obviously, but we will be able to now. What is in there? Sorry, I've forgotten what files are in there. Okay, so we've got a few files in there. Well, there's one that's simple, isn't there? Info, I think, is a simple one. Yeah, I think info is a simple one. So let's run with that. So paradev testdata.templates.info, and we're using Riscos file name conventions because we're doing it in the emulated system. Failed to open. Okay. Okay. I've got a warning there. What's that warning? Resource leak of file handle. Oh, no, wrong way round. if it failed, not if it was successful. Oops. Build it again. Right, there we go. Now it's complete, is it? CPU check, error. No, it's gone now, thank you. Just took its time to do it. Right, so run the test again. I think, because it got it the wrong way around, templates, open template file. I can't spell. Template file, there we go. All right. Let's just commit that. It's not doing anything useful, but let's just commit. Actually, no, let's not just commit it. Let's go and update the test code. So here's the test code here. So it builds the tool. Actually, I don't need to install this. I just need it to be built. Okay. Build the test program. Blank line. Test that it runs. Wimp templates. Oh no, it's in AF32. AF32.wimp templates. Test. Copying the. I'm just copying this, aren't I? That there. So now commit that, and we'll have our CI system do the testing for us. So add a simple test to invoke the tool on a template. The test will just try to process a template file. There we go. All right. And if we push that now, we can go back over here and have a look at the, is it this one? This one here. Too many windows. Let me move this window, this tab all the way down here, because this is the useful bit. So this is the testing on the CI system on GitHub. It's built it. And it opened the template file. Was successful. So that's a good start for us. We've actually able to open a file and then pass it back to the system. There's nothing else we're doing. Now, we're going to need to do a bunch of file reading and access to different parts of the system. So this is going to be a little bit tedious. But first thing I want to do is to have a look at what Riscos Pyromaniac does, because I've already implemented this in Riscos Pyromaniac. So let us start out with that. So let's add in the source to Riscos Pyromaniac as a window here. Here we are. And then we'll have a look for the file. So if you have a look for Wimp Template, Python file. What's that look like? That looks like it's a template reader. Okay. So this is the implementation of a class that loads templates. This is a class that actually does the standard operations. So this does open, close, and load. These are mirrors of the system calls that are used. And it just invokes the main template object. So what we're going to be implementing is, if I just scroll to the top here, this template handling. So open is basically creating, run the constructor. So let us have a look at this, shall we? Take a copy of this code and we'll dump it into this open function because we want to do the normal operations on it. So let's have a look. Kareem has just asked which language. I'm not sure which you're talking about. So this is Python. This is the code that I've already implemented. So there are multiple implementations of what I'm trying to do. The initial one is in assembler, and I'm not touching that with a barge pole. And I have rewritten that in the past as Python code. Python is a lot more readable and understandable. So here's my Python code that I'm using. And then I am now converting this into C code. So what we're going to do is we're going to take this Python code and turn it into C. So here we go. We've already done the loading template file. We've opened it up. Font data off. Right. So here we go. We've got some more information we need to have here. So there is an offset, file offset T. I'm going to call it. Oops, that's not what I meant to do. Which is font data offset. Let's do type def file offset to there as a uint32 for now. Oh dear, I'm forgetting things. And because I've started using uint32, I need to include std_int. Okay, so there we go. So for this, it calls font data offset equals self.readWord. Okay, so we'll call this templates read word for the OT. Oops, no, not self. Oh no, sorry, OT to font data offset equals OX 1, 2, 3, 4, 5, 6, 7, 8 as a long unsigned integer. Oh, I'm not writing in C code. Then set the value to be 0. 0, so not null. Right. So that's the first thing we do. That's the first thing we do. That's weird, isn't it? Is that really the first word of the file? Surely not. Making me question it now. So let's go to that documentation I just mentioned. So this is the documentation on the window manager. I'm just remembering Alan wrote a very decent. Right, here we go. Is that linked properly? Oh, it hasn't linked properly. Give me a second. I'll just link that window to it. Properties. Come on. PRM window. Properties. Window capture is the preview window. That's better. Yeah, there we go. There's the program's reference manuals. So if we just look at that, we can see in there that there's a lot of chapters, but one of the chapters down here is, and Alan's probably going to correct me if I can't find it, it's the file formats chapter. Template files, here we go. There we are. So template files, here we go. This is what they look like. Right, apparently so. The file offset of the font data. And then, oh, interesting. The next three words must be 0. Well, since they must be 0, we wouldn't understand the file format if they weren't 0. So let's check them. Because, yeah, why not? Which probably means we need to actually give these a uint32 word. Okay. So first word should be font data offset, then 3 words of zeros. Okay, so word equals, equals. Actually, I could probably do this just as 3 conditions, couldn't I? If is not equal to 0, or next word is not equal to 0, or next word is not equal to 0. Go to fails. So I'll have a little label down here that handles failures. So when we failed, we free OT, and we also fclose OT to, oh no, can't do it that way around, other way around, there we go, and we return null. Now, also notice that I'm not reporting any errors here, so let's just leave a note to say better way of reporting errors. So one of the things I said earlier, and I'll stress again, is that I'm not implementing it to what the SWI interface needs to have, what the system call interface needs to have. I'm implementing it to what the functionality needs to be. And the reason for that is that we can then be more free with how we're doing it. We're not going to tie it to the system calls. And if we don't tie it to the system calls, we'll be able to include tests more easily. So that's why I'm doing it this way around. Right, so here we go. Here's a rather interesting thing. We're setting up a hash table in here, a map, which is going to be a little bit harder to do in C. But what it says in the documentation here is the header is followed by a series of index entries to data later in the file. And basically this is all terminated by a 0. So what we can do is we can actually read all of these into a block of memory. We may as well do it that way. And actually, if we're doing it that way, wouldn't it be easier if we actually used the template file structure, like properly? So surely we have a template file structure. We should do, because it should be in oslib. I'm going to use oslib because oslib is far more structured than most of the other operating system interfaces. So let us have a look and see if we can find this definition in oslib. I'm hoping I can find it, because if I can't, then will be a bit of pain. So open a new terminal and have a look at oslib. So the easiest way to do that is to go into oslib parser, because that's where my stuff is. If I have a look in here, I've already got a bunch of generated, in fact I'll just open this window, generated code in this. So this has generated different Pyromaniac modules, ARC64, some Pyromaniac interfaces, but particularly C module templates exists in here. And one of the C modules we've got in here is the window manager. So this is a stub module that implements the window manager. It basically has all of the SWI calls and things. Sometimes it doesn't work. Unknown name of a struct. Apparently that bit's gone wrong. I'll need to work that bit out. I don't know what I've done wrong there. I'll have to look at it later. But more importantly, in here we've got a types file, which has extracted a lot of data. Lots of constants. Lots of constants. Lots of constants. And then the template. So if we have a look for a template. Oh. Really? Do we not actually ever reference it? No, we never reference it. Well, that's very sad. That's very, very sad. So that's no use to us at this point. Oh well, we'll try it a different way. If we go into shell, we drop into the build environment, there is oslib in there. Oslib? Yeah, oslib lives there. So oslib, we're looking for, where's, I don't know which one it lives in, but it will generally be in the resources. So let's just have a look in resources. Oslib, oops, no, CD. Have a look in user. Is it in user? User H. Wimp, there we go. So have a look at user H Wimp. So this is a very similar file to what we had before, but this is generated by the original oslib. Templates. Same error messages. Oh. Well, that looks all very depressing and disappointing. Doesn't look like there is actually a template. No, it's just constants for those, some errors, and that's it. Well, that's also very sad. So, okay, I can't reuse things. That's not a problem. I would prefer to reuse things where possible, but if I can't, we'll just implement it, because that's what we do. Type def struct template index. Template entry, I'm going to call it. It's actually an index entry, isn't it? It's an index entry. Yeah. So index entry, template index entry T, and this consists of, let's go back to here. So this is the file offset, the size of the data, the type, and then an identifier. So that's pretty easy. And in fact, we can just load these into memory because it will be that simple. So we've got file offset, T, data offset, file offset T, which is the data size. Oops, semicolons on the end of it. Then we've got the entry type. So this is going to be an I can't do it as an enumerated type. uint32 underscore T data type. So define template data type 1 window. There we go. Because only type 1 has been defined. I think the intention was that we would have windows in here, we might have messages in the template file, and we might have things like reference identity numbers and things. So you can actually have symbols in here. But it never extended in that way, which is a little bit sad. That's just the way it goes. You can, however, operate on non-window objects. And maybe we'll do some work with that later. Right, finally, there is a identifier, which is 12 bytes, and it's control character terminated. TRL terminated. So, if you were here for last week's or last project's sessions, you'll remember that I created a C string, which was a control terminated string object library module. Library, file, source. One of those things. I've been using Python too much. Every file is called a module. Anyway, so this is the template index entry. So what we can do here is we can have a count of entries, and then we'll have a template index entry T, which is entries. Oh, that doesn't work. N entries, sorry. Indent this a little bit. There we go. Right, so what we're going to try and do is read this data into there. And the way I'm going to do it is, how am I going to do it? Yeah, I think I'll do it that way. What I'm going to do is we're going to count the number of entries, then we'll just load the whole thing into the entries. So what we could do is we could allocate memory and then make it bigger and bigger and bigger. But if we just count the size and then allocate a block, that'll be a lot more efficient, I think. I don't know how the original ARM assembler version worked, but I'm implementing it kind of in the way that if you look at the Python here, this is very similar way of doing it, but it's actually accumulating in one go because it's Python, it can do that. Whereas we're going to just do it as a, this is the way we'll throw it together. So count the number of entries in the header. So n entries equals 0. uint32 t data offset equals templates read word. If data offset is 0, I've just realized I don't have any way of flagging an error out of that we've reached the end of the file. I'll get it returning 0. That can be my end of file value, because we're not going to worry about it too much. If data offset equals 0, break. Okay. Actually, I don't need to do that. Do I need to do that? And then do n entries plus equals 1 plus. And templates seek in OT seek by the current address. Not that, sorry, no. Size of template index entries. Typo netries. I can't even type it wrongly. Thank you very much. Entries. Thank you very much. If I start commenting this section out, then this code should become valid again. And if I can save it, I might start getting some warnings from the compiler as well. Maybe. Hopefully that's right anyway. Now created the, actually counted the entries. Should go inside the brace because we're actually doing a number of things. So we can read the lot into our workspace, for which we're going to need a structure that can do that. So template index entries, entries equals malloc size of what? Index entry. I've got used to just typing some of the letters that are in a token and then pressing tab and assuming that the editor will complete it for me, which is a little bit lazy, but it works. Oh, not times 4, no, times n entries. There we go. Entries is null. Go to failed. What's my take on AI, says Sleepy Dev. It's very useful for certain things. For coding, I've not spent a lot of time working on it myself, working with it myself. I'd like to spend more time, but I just haven't had the opportunity realistically. It's very useful for suggesting do something like this. In not the last project, the project before that, the first thing that I did, the was it disassembler? Oh no, I can't remember. No, I think it was one of my private ones. I basically set it a task of write some Riscos code that does this problem. And it wasn't a long thing, it was just maybe, I don't know, 40 lines or so. And it produced me some code that didn't work. But it was the right shape, and it just had a few mistakes in it for specific to Riscos. So I found it. Sorry, no, I'm not 64. I'm only 48. This is for the 64-bit Riscos that I'm doing. I've definitely been coding in C for 20 years. I think I started in 95, so actually 30 years now. I'm old. I still think no, it's fine. No, don't worry. No, maybe I look 64. That's the drain that Riscos has on you. I'm sorry. Yeah. So I've been writing stuff for a while, but I haven't really spent the time with AI. As I say, the time that I did that, it was actually quite good and it helped speed me up. It's been useful in my work. So my day job is DevOps. So I do CI pipelines and things like that. So yeah, that's my day job, and I use it a little bit in there to help me out. Sleepy Dev. So yes, a quick summary. I'm building a library that will read a set of information from a file format. So the file format is called Wimp Templates, and we're going to read the data from it and process it into a form that is useful elsewhere. So it turns template files into objects that can be displayed on the screen. That's what it's trying to do. So it's a lot of binary processing and just data processing. There's a little bit of information in case so Dave has said if using structs for your template seek is iffy in case the struct size changes over time. That's a fair point. So what I've tried to do here is define this to be I shouldn't define it to be that. I should define it to be uint32. So it's explicitly, it is always that size. I should do that. Do I work or am I retired? I'm still working. I've got another 10-15 years before I can afford to retire, unfortunately. Yeah, easily. The compiler could pad it. This is the file format. Be aware of structure padding. Use, what's it called? Is it packed? It's packed, isn't it? My compiler doesn't support packed, so I'm going to just leave it as a note for now. Sometimes they retire early. Sometimes they've got enough money to do that. I have not chosen a path that has made me rich, unfortunately. Yeah, sadly not. But Dave is quite correct that we should probably... As I'm going to read this indirectly, should I be? Struct compile time check template index entry bracket size of template index t equals 3 times 4 plus 12. Question mark 1. Right. This is a nasty trick. Dave says he redid the font file format to use Python struct pack strings. I've considered doing that. I thought it would be rather quite inefficient, but actually it's probably a quite nice idea, isn't it? That might be a really quite nice way of doing it. Yeah, Sleepy Dev, I don't use a lot of the autocomplete stuff. I just, aside from typing, so if I type template index ents like that and just press tab, it'll give me the things. Otherwise there's no auto completion online. I find it gets in the way. I haven't really tried many of the clever things that can be done in modern IDEs. This is showing my age, I'm afraid. I'm not used to those things. Actually at work I do use them a bit more, but not here. So, whilst Dave is probably correct but relying on that is not going to be reliable. That check should then ensure that we do have a reliable thing. Dave says that apparently it's in the Cunningham Pike book as well. I'm doing things that some of the clever people use as well. I may have learnt something over the years. So then I want to seek back to the seek set here. I haven't actually implemented these functions, I've just realized. So sorry, I'm not sure we would be able to do that anyway. Although sadly, AI will probably be able to do that soon. There is a rather neat. You've given me another digression here. XKCD, overzealous auto configuration, I think it's called. Zealous auto configuration. So it's this one here, and this really did amuse me because it's starting configuration, searching for Wi-Fi, found no open networks, found a secure network, trying the common passwords, checking for vulnerabilities, none found, connecting to Bluetooth phone, calling school, found the children acquired, negotiating for password. Like, no, stop doing that. AI has just gone off on its own route and started doing things. The Sleepy Dev says, is it possible? Well, probably more so than you might think, because if you ask AI to do something and it has the ability and access to do stuff, it may try and do that. Whether it will be able to put together a reasoned logic chain to do that in its current form, using basically chaining together things that people have said previously, I don't know. I don't think so. But AI has proved a lot of things, and it's proved that it can synthesize certain things, and it can do it much faster than you could ever do so. So consider somebody has accidentally, yeah, it's the blinds behind me. It's just shining through. If at some point, for example, AI had been trained on a telephone book, for example, and it had been trained on how to extract that data in some way, and it had been able to do some of the other operations that were needed to do that, it would literally just be chaining that together and extracting information. If somebody had at some point given it an example of, oh yes, P. Robinson could be Patricia Robinson, I don't know anybody call that, but that's came to mind, then it might go, well, yeah, that's a girl. Identify the phone number, zip code. I can do the zip code lookup. Sorry, zip code is the US thing. Ours is an area code. Sorry, it's not a zip code in a phone number, is it? It is an area code. Sorry, I apologise. But it might be able to look that up. And if you've got a phone book, it may even have your address listed in there as well, if it was a company name or whatever. So there's a whole lot of things that are actually quite scary there. But can we rewrite RISC-OS with AI? You'll end up with the equivalent of what an intern would have produced. You'll spend a lot of time having to fix stuff, basically. It really does matter what you've trained it on. If there isn't a lot of data, then it's going to be difficult. So, yeah. Anyway, what I was trying to do here was OT to entries. So we're trying to read in the headers here. Entries is entries. OT n entries equals n entries. And then we should be able to do, no, I'm going to have to do reblock. So templates, read OT into entries of length. That's the length there. Okay. Makes me check we read everything. Okay, so now we've managed to basically read the index entries. So I want to go and do a little bit of debug, I think. So for my yeah, we'll just do it as a bit of debugging here. Might as well. Equals 0. I is less than empty entries. I plus deep templates open red header dprintf minus 3 I. Oh no, 3 I, 3 again. So I've forgotten what the data format is already. Offset size type and then a name. So ouch. Offset percent I. Actually, we'll do it in hex. 05x size and 04x percent type percent I, and then we've got an identifier which I'm just going to omit from there for now, just so we get something out of this. I'd like to get something done by about in about 10 minutes so I can take another break. What's my advice for people who are starting in coding and stuff? Have an interesting problem, something that you care about, and try to solve it. That's how I would start out if you want to start coding. So whether your problem might be, and do start simple, because you're going to find yourself getting heavily bogged down. If you want like, oh, I want to be able to draw like Picasso using AI, you could probably do that, but it's a bit more tricky because it's you trying to do it rather than AI trying to do it. You want AI to help you. I just want to do it myself, but in place where I work, there's full stack. They ask me to do it faster, so I end up using AI too much. Right. Okay. That's a more interesting question. What for that? Use the AI, but when it comes to what it's doing, have a look at what's going on behind the scenes. Don't just look at that's done the job. Have a look at why did that work. Find the documentation on it. Find what the calls are doing and why it's doing it like that. Not because it's going to learn things, but you're going to go, oh, I remember how that worked last time. And then you can ask better questions of the AI and better questions of yourself. So if it turns out that the AI produced code that was quite long and did a lot of operations, it's useful to understand why it did it that way, because probably it's stolen that from somebody else who's written that code and they've avoided a lot of pitfalls. And if you start modifying it, because what will happen is, in almost every place, you'll get some code written and then your manager, your boss, marketing, sales will come along and say, do that, but do it slightly differently. And you'll change the code and it'll break. And it'll break because you didn't know the subtleties of what went on behind the scenes. You can tell AI to change it to do that, but it can only do so much. And sometimes it's faster to just know, oh, that's going to be easy. It's also handy to know when it's going to be impossible. So if the particular bit of code you've done does it a certain way and it doesn't work for certain things, it's not easy to extend. So I can't think of a good example now, but let's say you've written a bit of code that goes and resizes a JPEG to be a particular size. And they come along and they say, oh, I want you not just to resize it, but I want you to color map it as well, change the colors so it's brighter or something. And you ask AI to do that, and it goes and rewrites the whole lot because the way it had originally done it wasn't set up to do color transformation. So that's the sort of thing you need to be learning about. Also, the learning about what you think your manager is going to ask for next. Because if you can ask AI to do something thinking about a certain method, so create me a JPEG resizer and allow it to be to have the colors changed in it, would mean that it would get closer to what you think you're going to need in the future. Basically, it's just requirements gathering and thinking ahead. There is a principle called "you ain't going to need it," which is don't overthink things. But that means that if you apply that rigorously and don't do anything more than what you've been told to do, you're going to end up having to go. I've created a JPEG resizer. I've made it work with this size. I've made it work with JPEG's CMYK. I've made it work with this thing. And you've gone off in one direction, and then they go, "Oh, actually, can you make it work with GIFs as well?" And suddenly it's like, I've got to do a whole load of extra work. Whereas if you thought about that from the start, create me an image converter that can do this, then you start going in the right direction. Anyway, that's my suggestions. Again, I could be wrong, and it's possible that modern development is a lot easier than I even know, because I don't do things that way. I feel lost in my life, so I don't know what I'll be able to survive in this world. If you are struggling in your personal life, talking to somebody online is probably not going to help randomly, but find some help. Help can come in many forms, whether it is randomly talking to people that are of the same mind, or whether it is your friends. Friends and family can always give you something. Being able to say, I don't know what to do, I'm stuck, what's going on, the world's crazy, I feel lonely. I don't know your case. I've had my own problems in the past, and I have in the past not known how to ask for help. The interesting thing is that when you're at school, you've got a lot of people around you and you still don't know how to ask for help. They tell you that you can always talk to teachers. You can tell you that you can talk to your family. They tell you you can find your friends, but then it's still hard to do. And as you get out in the world, that gets even harder, in my experience. My experience is not yours, so you may have different feelings. But that doesn't mean that there aren't people out there that can help you in whatever it is, whether it be being unable to do things, or being able to be productive in the world. Feeling being useless is what Sleepy Dev said. I think that is everybody feels that way, and that's not dismissing what you're saying. It's just everybody feels that way. I feel that way. So I'm talking about a whole bunch of things that I've learned over time. My attitude to things is that I try things out and I try to do them. I have always known that I'm not the best. I can't do things. I have to overachieve on things. So you said you want to make your parents proud and you feel lacking. Well, I can relate to that. I can definitely relate to that. Sorry, I'm looking over here because that's where your text is coming out. My parents weren't around when I was little, and I found it very difficult to sort of get their attention sometimes, and so I want to try and do so much of them and things. Now these days, I'm less worried about my family, but I still try and push myself to do a lot of things, and it never seems enough. The thing to remember is whether your parents are there for you, whether you feel you couldn't do anything for them, whether you feel you could, they love you and you love them. Maybe you've got problems at home, I don't know, or wherever your parents were. There are always things that you can fall back on them for. If something goes wrong, you'll be able to talk to them. I mean, unless something catastrophic happens, but then you'll find other people in your life who can help you. Your friends can also act as family. One thing to also be aware of is that family in this world can mean different things to people. It can be your biological family, it can be adopted family, it can even be the people at work or the people you go to clubs with. So just remember that you've got opportunities to talk to them. I'm sorry, I'm talking a lot. I don't know if I'm being at all helpful or making any sense to you. But if you feel you're lacking, have a talk to people. Have a chat to your parents. Have a see what they say. If they're good people, and almost certainly they are, they will tell you, of course we're proud of you, of course we love you, and you are valuable. It's absolutely fine to bring things up. I'm happy to answer questions, whatever they might be. But do remember that looking for help is the first stage of finding help. If you feel that the world isn't helping you, then you can go out and look for things. It's hard sometimes, but do feel you can. I don't want to dismiss your feeling lonely and the like. I'm glad you've come along and had a chat here. I am always willing to chat about anything that comes up on this channel. And I don't know, you might be just feeling a little lost at the moment, or you could be having real difficulties. So I will chat. If anybody else wishes to chat as well, feel free to say. Just remember that everybody feels bad at times. Everybody feels that things are not going their way. I've recently started a new job, so I'm still feeling that whole imposter syndrome, where I'm not quite getting some of these things because there's a lot of stuff that I'm doing at work that I've never done anything with this before. I can kind of do stuff, but it's hard. Right, okay. Thank you. I shall continue with things. I apologise for just rambling. I'm happy to chat. I will also just keep talking. Yeah. What was I doing? Where were we? I'm looking at my code and going, that looks like too many space people in there. If I just put minors in there, it just comes a nice little alien there. No, that's not right. I'm sorry. I'm just getting a little bit weird on this. OT entries I dot offset. Hang on a second. Yeah, I'll just finish writing this line and then I shall take a break, I think. Let's do that, because I think that was quite an involved thing. Yeah. Take a break. Just get this line finished and then we'll have a break. Sorry, my wife my wife has just reminded me that it's a good time to have a break as well. So I got married not so long ago, and it's quite still quite novel and new and exciting. I don't get excited all that often, but there we go. There's the data type. All right. Right. Let's just have a quick see if this builds. And if so, all will be good. And if not, then we'll know what to do. Talia Ferguson is here. She can answer your question. I don't know what I'm doing now. Yes, Talia Ferguson is my wife. My wife. Oh, I'm building in the wrong area. No, don't do that. That's the wrong thing. Build over here. Oh, of course this won't build. I've got half my functions missing. And apparently I can't write code either. All right, so yeah, lots of breakages in this. Expecting to... Did I get that wrong? Oh, yes. Sorry, that's the name of the struct. TIE. And we'll call this. There. Let's build that again. That should be more correct. Oh, no. We're defining the struct as... Yeah, I can't write code. Yeah, I think that's more like it. Yeah, that's more like it. Oh, and I forgot my semicolon on the end. He's very, very clever, is my Talia. Right. It's still broken, but it's broken in ways that are more amenable. So what I'm going to do is I'm going to take a 10 minute, 15 minute break, and then we will come back. All right. That'll allow me to be a little bit more calm. Grab another cup of tea, I think, or possibly, I don't know if we've got any pineapple juice left. I think it's all gone. Possibly Coke then. And then we'll see how we're doing. All right. So, Sleepy Dev, have a restful time. I will be back in 10 minutes. Don't get stressed, and remember that sometimes you've got people around you to help. All right. Right. Okay. Gonna have a break now. See you in a bit. Hello, I'm back. Oh, we got some nice chocolates, and I've only just opened them, and one of them has a rather alcoholic-y one, and it was a bit strong. I'm not a big alcohol fan. Oh, right. Where was I? Yes, I was trying to get this working and realizing that yes, we've got some stupid errors in here, functions that aren't implemented, and yeah, that's all that's meant to be on that line. Anyway, that one there. What else we got in here? Seek isn't implemented, read isn't implemented. Oh, n entries, not entries. That's good. Yeah. Command accepted but found int. Oh dear, that means I haven't closed a brace somewhere. Here we go, I haven't closed it here. Right, so rebuild this and see if we get any better build out of it. Just check that we're actually live. Yes, I am talking, it's okay. A number of times I've started talking and then realised that I haven't unmuted things, which is a bit dumb. Right, okay, so we're now literally just looking at the inventing functions. So what's that? Oh, that's okay. Right, so let's implement some of these. Read word, Wimp 32. Yeah, Wimp 32. Open templates. T. Templates read word. I still cannot spell. Read a 32-bit value from the open template file. This is C code I'm writing at the moment. I'm writing it to process a template file, which is a binary format file, into something we can actually process. Template we are reading. Oh. I'll come back to that later. I just had a thought, yes. Word and red. So, Wimp 32t, word, fread. I can never remember how fread works. Fh. Hello again, Sleepy Dev. 1. No, I don't. I can never remember it. Man fread. Destination, size, number of items, stream. Okay, so I got them around the wrong way. So, destination is word. There's that one. Size is this one here. And then the number is 1. Or is it the other way around? Should be the other way around, shouldn't it? Because I want to know that we've read 4 bytes. Actually, no, it'd be better for me to do it as size equals there, and then return that we read 1. No, I'll go this way. If read equals size of word. If it's not equal to size of word, return read EOF. So did I get to eat anything? I did have some chocolates, which was quite nice. A bit of chocolate, and I got myself more tea as well, so I'm at least able to function. Right, so that's the read word function implemented. Now I've got to do the read function, which is a generic one that reads a size of data. So, what's that? Oh dear me. Right, let's describe it first. Read an arbitrary size of data from the open file. Restart dest int size into dest. Don't need that, and won't run, and we'll just return the amount we read. And we'll go again with templates. Seek. So these are just wrappers around fseek at the moment, but they could be implemented different ways if we wanted to, which may make it more efficient. Offset seek how seek underscore set absolute seek underscore cur relative to current seek underscore end relative to end. Unfortunately, this is just fseek. Oh, not the word we read. Amount data we read. Return int, not caring about that. Return fseek, ot to fh, offset how. These could actually become macros. Seek, I've not renamed it. Right, so there's the template helper functions done. Let's build it. Do it built. Word declared but not used. Where's that? Oh, okay. We didn't need that after all then. Let's get rid of that because it was in here. So we I'm reusing the size value every time, so I'm going to just put it in here. Size equals that. Size in there. I'm using the size here as well. If it didn't read, okay. Printf's got upset there. What's wrong with that? %i format string requires int, but the argument is unsigned int. Should be a U there though. Okay. Build that. Oh, what? Oh, I missed my semicolon up there. Right. Have we got anywhere with this? We have. Okay, so if we run it now, yeah, people are generally quite quiet here, I'm afraid. Sorry, Sleepy Dever just said that people are quite silent, which is fine. It's just the way things go every now and then. Oh, that's a pity. It's told me that offset 0, size 0, type 0. That doesn't seem right to me. In fact, that seems quite wrong. Let's have a look. So if we have a look at that file, in words, test data./templates info. So have a look at the file. Right. So the offset of the what's it called? Oh, yeah, offset of the I forgot what it's called. Where's the documentation again? Come on, docs, where are you? There you go. Offset of the font data, that's right. Value 0 means none. So value -1 means none, sorry. So what we can do here is we can do might as well print it out. Font data offset equals %u. It's an offset, so let's have it as a %x. Oh, 5x, shall we? There we go. There's the font data offset. And then we read 3 more words. That pads us out a bit more. Reserved, 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 yeah. And then we've got a series of index entries, which is these. Yeah, that looks all right. Oh, I've seeked the wrong place. I've seeked to offset 4 and I should have seeked to offset 16 because of the header. That's why. So that's probably what's gone wrong here. Right, start again. No, that's not what I want to do. I want to run the program. Run the program. Oh, except I didn't build it because I misspelt dprintf. Come on. There we go. No, it's still giving me 0, 0, 0. That's wrong. Did I rebuild it? All right, now I've rebuilt it. I didn't rebuild it last time. Dear me. Right, this time we should be getting something useful out. Right, offset 2C, size 1F3, type 1. Type 1 is window. So we're good there. So in the last project, I created this C string, which is a control terminated string. So we need to copy that over to here. Really, it could be moved into a little library, but right now we're just going to do it this way. So what was it? What was the thing we were doing last time? It was system vars, wasn't it? System vars. CS string, not control or space. Oh, it's control or space terminated. Ooh. We need, it's not control or S. Okay, well, we'll call it control string instead. Should we call it control string? Yeah, we'll call it that, and we'll do the same for the header as well. And then what we'll do is we'll modify it. I haven't got a H directory. we'll modify it so this is now a, ooh, that's not what I wanted. No, stop it. That one. Thank you. Now I can see it. Right, so this is a control terminated string processing. Hi Andrew. Hope you're all right. We are working our way through implementing Wimp Templates. Just putting together some functions for control terminated strings, not control space terminated strings, because it's very exciting. We've only really just started doing implementation, really. Still tired from the show, but just remembered the coding. Well, I'm glad you've made it. Those shows can be quite exhausting. I'm still tired from the wedding. See, Alan said he thought it sounded exciting. I thought, oh dear, they're going to be disappointed because it's not that exciting. There's just a lot of data processing. I mean, yeah, it's interesting, but it's not. Well, I don't know. I hope it's interesting to people. Oops, didn't do that right. Control. That's okay. Let's rename all those. Equal to. All right, I think that's all the control and string. Eventually, I'll just make these into a library and we'll be able to share them and stuff, but I haven't done that yet. Oops, that one's also had a replacement. Oh dear, it's already the 5th of November. Oh, it's 5th of November. I'm assuming that means we'll have quite a few fireworks tonight. We've had them most of the week actually, but there's been lots of celebrations going on, obviously. Okay. Oh, and these aren't, yeah, I need to change the comments as well. Not written very consistently, these, but it doesn't matter. Right, there we go. We've got those implemented now. Let's just go and dump that into the make file. CTRL string. And have a look. Not, yeah, that one. Right. Riscos ammo. Let's put the two together, shall we? pyrodev. So there's the test command. Riscos ammo and okay, well let's quickly turn on fortify equals no. Fortify build. I didn't rename that variable. Expected bracket, oh, because it's not called CS string, it's called control string. Have I got another one of those I've made a mistake on? Yeah, there we go. And I've used CS here when it should be control. This is where a modern editor, where I can just do a refactor, would actually be a lot easier. Just rename all that variable, but yeah, no matter. undeclared name, yeah, because it's not called CS. Okay, cool, that's built. So now if we go back to the main function, so here's where we've copied things and now we're printing out the header. We should be able to do identifier here, %.start x. It should be control strlen ot to entries bracket I. Oh, we should probably terminate it. If we terminate it in memory, oh, that's a good idea. We could terminate it in memory. So len equals control strlen of ot entries bracket dot. Is it identifier or name? It should be called identifier because that's what it calls it in the. Yeah, it's called identifier. If len is greater than 12, greater than 11, it's invalid. Is template handling a separate module on Pyro or just part of the main Wimp module? It's template handling is, here we go. This is the code. Whoops, where'd it go? Here it is. Right. So this is the code. So it's not part of the Wimp module because there is very little that's actually part of the Wimp module. And Wimp module doesn't do very much. So template handling is made up of a template class which handles the manipulation of the template files, and that does all of this work. That's what we're going to be implementing right now. Big function. And then there's the Wimp Templates resource, which is a resource in Pyromaniac is a thing you can identify. Essentially, it's a library in terms of C code, and like that's what we're going to think of it as. And this resource implements in Python code the open entry point, the close entry point, and the load entry point, and it provides them with like standard function entries, like parameters on entry, and then some return values here. And in the window manager itself, so if we have a look in wimp.py, I think it's actually in it. There we go, here's the window manager. Come on. Come on. I want this bit here, please. Oh no, that says nothing. Okay, Wimp. I'm a little confused now. I thought it was that one. Actually, if we go to that and then we'll look at the source code. So where are we? So here's all of the parts. Oh, we don't have a Wimp module at the moment. Yes, there just isn't a Wimp module at the moment, I don't think. There's just the SWI calls that we handle. So we directly handle the SWI calls instead. But there is a branch that has the window manager on it, which does call this in. But basically the resource means that we can just call into it. If I look in Wimp template, so yeah, the first one of these is the SWI calls. So these are actually directly registered. And all they do is they find the resource and then call the open call, call the close call, close the interpret the parameters and then return and then convert them back. So it's all about converting things in a different way. But the point is that it's kept separate, and I'm doing all of the processing in more modular way. There's no need for us to consider the window manager as a whole. It's made up of lots of subcomponents that we will then bring together. That's basically what I'm aiming for. Identifier. Failed. Okay, and then we may as well terminate its OT to entries. I hope you can't hear those sirens going by. It sounds like there's an ambulance flying down the road. One of the problems with the having the Adam books nearby. Right, yes, Andrew just said it's more fragmented approach, which makes it much more tackleable. So I will quickly go back to the intro that I did at the very beginning. So hopefully I'm not going to bore people, but so all of in the plans that I've got here, so have a look at phase one. Phase one has just the Wimp templates in it, nothing else. It's all right, don't worry about it. I'm happy to repeat. So the Wimp templates is just one of the parts I want to do. But if we have a look at the templates itself, so click on here, the plans now show us that phase one is where most of the work will happen for the internals, and then we'll wire it up in phase four. So if we now look in phase four, this is desktop networking and advanced functionality. It tries to pull in a number of bits of the kernel getting implemented, and a lot of the window manager, which I've started to break down some of the parts of what's needed on those. And because they're all individual parts, they can in theory be worked on by different people. These are largely being broken down by what I know is in the window manager and the way that I've implemented it inside Viscos Pyromaniac. So for example, it's not in this one, but the font handling and the text rendering is all handled in a completely separate area to everything else. And then on top of that, we build window rendering and icon rendering. And then on top of that, we build command window, because command window is just one instance of the window rendering. And it all builds together to make a more cohesive whole. And sprite rendering can come in as well, but it's a slightly later thing because icon rendering just goes and does nothing, and so on. And sprite rendering obviously has to have sprite pools that are managed as well. So that's the way it's sort of heading along. I've broken it into different phases so that they can be done over time. They're not like something that happens like all at once, and people can start working on them in different ways. If somebody wants to work on a different section, they can, and they don't have to work on it in a particular section. As you can see here, I've already done most of Owner Banner, even though it's not planned to be done until this is phase four. So not needed to be done until then, but I got bored and so I implemented it. Things like Resolver is actually strictly built at the moment. Oh no, it's not. Resolver isn't built. No, I couldn't get Resolver to build because it uses the internet libraries. But there's a number of things that could be built up. Syslog probably will build as well, but we'll get around to that. Anyway. Yeah, Andrew says, yeah, I got bored to implement it. That is how I think about things. Like I want to feel I've achieved something and done something, so I go through these things. There's a lot of work that has obviously been done, and if we click on current status, current status here, you can see that there are some modules that I've worked on, some that I've just got building. Video teletext works fine. In simple tests it seems to work, but then I've just built stubs for those modules. They're not really doing very much. System Bell, it's got services it provides one service, so it's very easy to implement functionally. And some of the others they're already C code, so they're just easy to build. Printer buffer is assembler one that's been converted. Anyway, that's how I've broken it down. If you look down here, we can see on this actually I've listed the window manager as a single entity. Where's it gone? I've lost it. I had the window manager a second ago. There it is. Window manager is listed as a single entity, but should have been broken down in here to many different things, because window manager as a whole, it's got a lot of things in it. A lot of SWI calls, a lot of services it handles. It handles some vectors. It issues a lot of service calls, and it does a lot of its own work as well, and works with a lot of part components. So there's a lot of work to do there. But each of those little parts can be done individually. And as I've mentioned before, there's separate tick boxes for, is it working in 32-bit? Does it work in 64-bit? And adding in more functionality for each part of things. And as I find there's more things that need to be done, I add things to these descriptions. I'm doing a longer presentation about the Viscos 64 Pyromaniac work on the 17th, which I'm going to have to write some planning for and things I haven't done yet. But that I will talk more about it then, in probably a little bit more coherent detail, I'm hoping. I hope that helps anyway. How do you think through this? Pre-planning so much. Is it just because you've done these things many times? Yeah, Shantanu said that. I spent a lot of time working with Viscos original version, classic version. I spent 6 years working with that full time. And then for the past 6 years or so, something like that, 5 years, I've been working on Viscos Pyromaniac, which is a re-implementation from scratch. So I know a lot of what's involved. The reasons for having this stuff planned out is partly because I've done it before, partly because I know there's a lot of things that need to be done, and it's really demoralizing to just have this block of work. So I try to break it down into smaller segments that can be actually managed by an individual like myself, or given to somebody else with some detail. The other reason for breaking it down like this is because then other people can see the problem and go, oh, that's not as hard as I thought it was, or can I just do this little bit? Or how are you getting on with this bit? It should be pretty easy. And then they may wish to get involved because they can see that it decomposes to smaller segments. That's the idea of it. So it's not just for me, it's also a PR exercise to prove, look, these things can be done. And it also shows that there is progress happening. So a number of different reasons. There's me wanting to understand how to do things, wanting to be able to communicate that to people, wanting to be able to show that the problem is manageable and able to be broken down, and that maybe they can be involved as well by taking a small segment of it. They don't have to jump into things. One of the things that commonly comes up in the Viscos world is, I don't want to have a look at a whole load of assembler, or I don't know how to write assembler, or I don't know how to extend this because it's hard to do. And the answer is, so don't do that. Work out what's actually needed and implement it in some way that you understand. My implementation here, I showed earlier, so you wouldn't have seen it, but I'm quickly going to dump this back up here. So this is the template class that is implemented in Pyromaniac. So far, in the C code, we've implemented about this much. And some of that's because it's been a little bit more involved setting some bits up. But also, I've been chatting for a long time as part of this session. And the reason I talk a lot is because people ask questions, and because I want these sessions to not just be about writing code. This is about how you think about things, that they are manageable, and that you're able to take something that's been rewritten in a different way and go, oh yeah, I can do that. That's not hard. That's the idea. Once I get into this, it will actually get much, much simpler. But at the moment, it's a little bit more tedious. But we're getting there. We're definitely getting somewhere with it, because we now have, well, sorry, apart from it not building, we've got parts of the system working. Let's just rebuild it and see where we're up to, because I think, oh dear. All right, so let's do that. Yeah, that was me terminating the string. Oh, and I haven't included the header file. So the idea of this is that we start breaking down what's needed into simple sections of code. And this is just a command line tool. This isn't even in a module. One of the things about writing Riscos modules is that it's really hard to debug them. It is just painful. Even if Pyromaniac makes it a lot easier, but it's just difficult. So why bother? Write it as a library and then build it into the module later. You don't need to have it in the module straight off. So if we just rebuild this again, hopefully we should be looking at controls to learn. Oh, come on, have I controls to learn? Did I not? I didn't include the header. I've done a lot of this stuff before, and yeah, I don't want to make it, oh, I've done it before. I've done it before, so I'm trying to show other people how you can do this. And importantly, you keep screwing up, mate. And it's not, no, it has got an identifier. Oh, it doesn't have identifier. When you screw up, you just keep rolling on and you do the next thing, you do the next thing. Illegal cast of struct. Oh, what? Oh, yeah, because oh, that's right, it should be identifier. Oh, in fact, I don't need to do that because now I know that it's a terminated string. So I can just identifier. There we go. So we don't need any of that. Not need a semicolon in the end. There we go. Oh, and close brackets as well. What does the template do? That is a fair question. And it's one that I shall now demonstrate. So, well, just let me get this. I cannot spell the word identifier. Right. It built. All right. Bear with me. I'm going to show you what the templates are because I should have given that context before. So we build the code, we're running the test program, and there we go. Offset 2C, size there, and an identifier name. Brilliant. Okay, so can you run that, please, in your own time? So I'm going to start up the full Riscos emulator. This is RPCMU. So this is a fast emulator. It's not used for debugging or anything. And this is a template editor. So templates. Oh, if you just give me a second. Zap. So just give me a second, I'll find, so this is a template editor. So the templates that we're looking at look like this. So this is the binary version of them. Let's put it into Word mode, there we go. So this has got a whole bunch of the data. This is sort of the things that you're seeing previously. And these templates, you can just see here there's a name called name browser, groupings, default, work area, a few other bits and pieces there. If you look at this, these are the templates. There you go, you can see they're named. And some of them are windows that look like this. Some of them just plain. They've got some text in them. Some of them have sprites in them and other different icons. So what you can do is you can see here, this is icon number 3. It is a text icon. It's got some sprites in it. It's got some centering. It's got a position. If I look here, we can see it's got position in there. So these template files describe what the window layout should be. And that allows us to be able to basically build up an application's design. So we're going to be able to load these. Load them in the sense of we convert them from binary form into something that can be used by the window manager to put things on the screen. That's what it does. So not very exciting, but the process of doing this is one of the key parts of the window manager as it gets developed. The info box, it looks something like this. This isn't the one that we were actually using, but it looks something like this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 icons in there. We may find out that there's some more in the version we're looking at, but it's going to be something like that, and they're going to have some text in them and things. And you'll be able to see that once we get the templates up and running. At the moment, we've just found the index that tells us what's there, because we haven't got much more than that. Not yet, anyway. I hope that helps explain things. Oh, RPCMU quit unexpectedly. Apparently it crashes when I close it. So, this has now all been implemented. In fact, even down to the how it was named and things. So, all of that can be done. Ooh. And we haven't got any way of reporting errors, but we have got a basic system of reading. Validation here, we should so leave some notes to myself. I like to leave notes and fix me's to say this hasn't yet been done, it should be done, and this is where you should do it. Check the offset and length are in the file. What else should we do in there? Oops, fix me. Should we check that the template names aren't repeated? Not sure if we should or not, but yeah. And that's about all we can really do there, because yeah, it's not very, there's not a lot else in the index that we can actually check. But that's now implemented, so we've now got something that can work. So let's add in C and add in the new files that we've added and commit it. Added basic opening of the template file. Now open the file and validate barely the header. Okay. And I'll push that in case anybody wants to check on it, in case anybody is interested in the repository. Come on, give me a click. Thank you. This is the repository that we're building it in. So you should be able to have a look at that if you wish. And yeah, there we go. That was successful. It all built and tested in 7 seconds. There we are. Brilliant. So, excuse me. The next thing we need to do is to be able to close the file. So, yeah, we have actually done something. We've achieved something. So if we have a look here, not this one. If we go back to the templates entry, so if anybody's interested, this is the actual wiki page that describes it. We've now, we've only done the opening. Okay, so I can't tick that one yet. I can't tick that box because we haven't actually done that. So let's get closing implemented, then I can tick a box. Because if I can tick a box, then at least I've done something, achieved something today. So that's why we have the boxes. We can say we've done something. So templates, close. Description of the function, close and open template file. So for the benefit of people that have joined us later, if you know Riscos, you'll know that this is slightly different to how the window manager handles it. Because the standard classic window manager doesn't actually have any the concept of multiple handles. You can only have one open at a time. But there's no point in us being restrictive like that. It's no harder, realistically, to implement it with multiple handles at once. In fact, it's probably easier to do that way. Is that right? Yeah. Right. Void. Right. So fclose OT to FH and free OT to entries and then free OT. We should, oh yeah, so that's closing the file. So let's put that in here. Templates, close. See? Closing file. There we go. Print out a debug message to say that we're doing it. And then have a quick test. Come on. Success! Woo! Yeah, all right, that's good. So we can now say that that's working and we can move on. But if I have got multiple files, I want to be able to keep track of them. So let us have a list of open files. Open template. Open templates. Ooh, cannot spell templates either. Terrible. In which case, let's just restructure this. So this section here. Yeah. Struct open template s next. There we go. Right. So now when we open a template, we can link it into the chain. And we'll have a chain of all of the templates that we have opened. So, oh no. Only when we're successful do we link it to the chain. So OT to next equals open files. OT open templates, sorry. Open templates equals OT. There we are. That's now linked into the chain. Make a note to our tracked chain. Which won't matter if we're only going to provide one of them. But if we do provide more than one, because in theory we could have one of these in each application, which would matter more if, for example, the window manager was multi-threaded. You can't have a multi-threaded system where it's one application is loading, preempted rather. You can't have one application that's still starting up and loading templates, another one that just can't use the templates until then. So it would matter in those cases. So here we need to unlink on the chain. Oh, open templates underscore t last. While oh no. Cur. So we do. Right. If cur equals OT. Closing the open template file, we close it, but we need to unlink it as well first. So first thing to do is star last p equals cur to next. There we go, that's now unlinked. and then we can just close the open template file and return. And return 0 for success, 1 for failure. There we go, I'll do for now. So 1, OT equals OT to next. And what else? Oh yeah, last P equals ampersand OT to next. There we go. So I think that should unlink us from the chain. We should also print a message here just for the debugging. And we might come up with some error handling later. Right, that's built. Can we run the tests? Closing open template file. Excellent. So that's actually gone quite well, I think. Git commit as a implemented the close of template files. Yeah, not exactly the most exciting, but one of the side effects of that is that we can tick a box. So let's go tick the box. Discuss 64 status. Oh, my eyes are itchy. Not sleeping well last night. I didn't sleep too badly, it was just a little bit too little. And let's have a look at what we've got in here. So in the features for templates, there we go, features of templates. We can now, oh, here we go. Yeah, we've proven that it works in 32-bit, but does it work in 64-bit? Should we try that? So ammo build 64 equals 1. I'm in the wrong source directory, that's why. Let's go back to the templates file directory. Build it for 64-bit. Come on. It's a bit slow. Switching to 01 really has slowed things down. Or maybe it's something else going on, I'm not sure now. Right, pyrodev 64. Same command we had before. Where's my command gone? There we go. That command. Oh, no. Come on, pick the command up. Same command. Oh no, that's going to fail because we're running the 32-bit version. Yep. 64-bit. Yep, so it works in 64-bit as well. We can happily tick that box. Woo! All right, and with that box ticked, I haven't got a binary I can really give to people because this is not really a useful thing to give people yet. Oh, I could build a module actually. I could build a stub module that just has these functions in. Should I do that? I've got about 10-15 minutes. Yeah, let's do that. Let's build a dummy module. Git diff. Not wrong. No, that's right. Yeah, so I'm going to build a module for this. Let's move the 64-bit stuff out of the way. Let's build a very quick module. So Viscos project create. Name is module. Give me a skeleton. It's going to say no, isn't it? Because it, yeah. Move make file to make file test. Do it again. I'll say C module. Yeah. So we've got that. Now to move the makefile to be makefile module, because I want the primary thing that I'm building to be the test code. Eventually I'll make that command take the name of a makefile, but I haven't got around to it. Right, so if I look here and then refresh my files, you should see that we've now got a module which is just basically Wimp Templates module. Give me a name here. Right, okay. So we're going to want to give it a set of SWIs. So SWI chunk base, COOO, error base, don't care. Oh, excuse me. SWI decoding table. There we go. So Wimp templates, and we've got 3 SWIs we want to implement. We've got open templates, load templates, and close templates. Those are the ones we want. And each of these SWI open template. You cannot spell that word. Close templates. There we are. Right. Viscous ammo. Make our module. And it hasn't got an implementation of those functions, which is fine because we can just implement them. We go into the module header here and find these functions. Whoops, come on. Find the functions. And then we drop them into here. Open template. Right, what we'll do is we'll return null just for now. So they're just not implemented, they return nothing. Okay. Build that. Cool, that's built. Now we need to know how they're actually implemented. So we just pop over here, we've got the PRMs. So Wimp open template, there's the call. So what do we have in here? R1 is the pointer to a path name to open. Fair enough. But we only ever have one of them. So Wimp, I'll say open template. Oh, this is all implemented in main. Right, okay. The Wimp only has one template open time if OT not equal to null, templates close it, and then we also want to know that it's pointed to a template path name to open. I don't know if you remember, but earlier I showed the riscoslib parser. So back in, let's go back to the top. Right. So this is the oslib parser stuff that I wrote ages ago, and we have some generated functions here. One of which was the window manager, and we had a brief look at it to see whether we had a template structure in there. But one of the things it does have in it is different SWI entry definitions. So I can just find open template, close template, load template. If I just copy all these, it's got all of the definitions already written for me. No, except that one, which I'm going to have to probably just trim down a little bit. But so rather than doing this, we can actually just paste this, get rid of those. So load template, yeah, we're not going to do any of this. Let's just comment all of this section out. close template just returns an empty null, and this is open template, so we can just copy our open template section from in here. So first thing to do, close the file if it's not there. Next thing to do is open the template. So ot equals templates open, and then the file name. If ot equals null, yeah, haven't done that yet. Otherwise, that's it. We're done. That is actually the implementation of Open Template completed, because it doesn't need to do anything else other than open the template. Yeah, it needs to report some errors and stuff, but we'll sort that out later. So this can now go. This can go as well, and then we can go down here. We can have a look at this, because this is closing the template, which is also very simple, because we just go if the template was open, templates close, and set the handle to be null. There we go. So I think that should give us opening a template and closing a template in a module, which is a little bit better. Doesn't work, but it's because I never extract everything. So let's extract all the files from this into templates. All of the code that implements template handling comes out of the main function and goes in there. Let's just pick all of this up, all the way to here, cut and paste. Come on. Templates. Template manipulation. Date today, 5th of November. It's not 5th. Did I write the 5th of November earlier? I did. I'm just confused. It's not the 5th of November. It's the 2nd. My world is not quite as sane as I thought it was. Hash include stud int.h, include studio.h. What else do we need? String, I think. String.h. Oh, we also had those debug things, didn't we? So I want to pick that lot up and put that in here as well, so we can do debugging. Okay, so there's the templates handling. Main for the template code here needs to include that. Oh, we need control string as well, don't we? There we go, control string handling. Main function now becomes a lot simpler. This is really, really simple, which is awesome. Module also needs to include templates. Templates really need to be able to type. And then we need a header file for this as well. So templates, which we can probably just copy and paste this, because it will be simple. And if no implementation, still going, there we go. No implementation. Not all of these are actually internal, so they could be statics actually, they don't need to be in here. That's needed, and all those are definitions. Cool. And then in the C file we can now remove, come on, thank you, include templates.h, and we can remove all of these structure definitions because we don't need those here as they're in the templates file. All right, makefile now needs o.templates. There. Build that. Oh, that's building the module. I don't want the module yet. I want the other one. I want the main. I did get an error though in templates.h. Oh, I forgot to I don't need studio or string. I may need control. If Gerph templates on the H, build oh, I haven't included studlib. That's because main hasn't been up. I haven't saved it. Right, now it's saved, it should rebuild it. Oh, forgot to include the templates header. Dun, dun, dun. This is where modern editors refactor operations would do really well, because you could take a section and just go refactor that into a file and it would be able to do it. But I haven't spent any time using those sort of tools. Riscos make module. The module's going to fail though, because it hasn't actually got the templates in it. So, oops, sorry, didn't mean to whistle. Templates should go in here. O.templates. There we are. Build again. Controls. Oh, because I didn't include the control string. Oops. No. O.ctrl string. There we go. Need that as well. Oh, and again, turn off Fortify. I had to comment it last time. Just put no Fortify, but we understand it. Hang on, didn't I? Oh, no, it has to go before the include. There we are. So now we have a module. When you're coding this project, what C level are you working to? I'm always working to C89. I don't have the source to a fully C99 compiler, so I'm always using it to C89, which means a little bit more pain, but I always have to do that. I have some of the source to a later version, but it's not my... I'm not as interested in developing a compiler. It's bad enough that I've had to build the 64-bit environment and everything else around this without having to also build a compiler as well. So, there's so many problems I can solve, and that's not one that I've been attacking, Andrew. So Andrew had asked what level, C level are they working to? Right. That's not what I wanted to do. What I wanted to do was load the module. So load module rm32/Wimp Templates and then drop to the command line. Basic. What's this? Wimp Templates. Oops. Templates. Open templates. What register was it in? It was in R1, wasn't it? Testdata.templates.info. There we go. I now have a SWI call that will then just pass the headers. And in theory, if I do it again, it should automatically close the template and then open a new one, which it did. Close the template and opened a new one. Wonderful. So, with that in mind, oh, let me just build it for 64-bit as well, because then I can feel at least comfortable that I've not broken that. 64-bit run. But of course, I don't have BBC Basic in 64-bit. I do have a PicOC. I could use PicOC. Oh, I could do that. Oh, would that be just stupid? Oh, it would be stupid, but it'd be cool, wouldn't it? Right, what I'm going to do, let's just finish this bit off. Riscos project. So there's a bunch of directories and RM directories, so I need to update the. Didn't you do something for? So Andrew says, didn't you do something BBC Basic for SDL for the 64-bit OS? Yes, I ported RT Russell's version, but the system calls interface just doesn't work properly. I could not. I had real difficulty making it work, so I've not abandoned it, but I've just left it for now so that I don't have to worry about it. So yeah, I did do that, but I've not got there yet. Eventually I'll come back to it, but I've only got one pair of hands and so much time in the day, and so it's not. There's only so much I can do. I'm not sure if anybody would care, but if you have a look at not that one. Where's this bit here? So if you go to the RISC-OS 64 status directory, there's now a languages section here that talks about what languages are available. And what is not available. So there's a lot of things that haven't been made available that I would like to get done or would be interested in somebody else getting done. But I haven't got there yet. Again, only so much time in the day. But there is actually a section to be up for, if anybody wants to build things, they can bring those on and start doing things. So at some point, right now, well, I'm going to do this very quickly. So add in all the bits that we've just added. Make module CNH and CMHG as well. We also, so because we've built, although we've built the test code, we've also got the module we can build as well. So if I have a look in row build here, so build the test program, and then if the test program works, or we should run the test program and then build the dummy module. There we go. I'll give me something out of it. Install. Copy artifacts. Copy. Cedar. Copy, I'm trying to remember RISC-OS syntax. AF32.wimp templates to artifacts dot test. Without confirm, verbose, forcing overwrite. And then RM32 as wimp. So what we should get then is a built set of artifacts. As a create a dummy module. Push that, and once it's been pushed, we should see it turn up over here being built. There we go. Building. Built the test, built the module. All finished. What was that? 14 seconds. And then we've got a output from here, which hopefully, come on, where are you? And, no, don't do that. Hello. That's not the window I wanted. I've lost it. There we are. This is what's been built. Wimp templates and a test. So people can try that if they wish, which is cool. So with that merged, I can now do RISC-OS AMU 64-bit builder module. and 32-bit build of the module. Move OM32 to FFA. Just copy the modules over to there. Right, so they've been copied over to the status repository. So we have a look in here. We'll see that there's a small change that I've made to the templates and the Wimp Templates modules. So we'll add those to that. Add the updates. Oh, did I actually update it for the to say 64-bit worked? Yep, I did. I've not actually implemented Wimp Open Templates, so I'm just going to leave that unticked for now. It's not, the dummy version is implemented. Add the updates for, add the implementation of a module with dummy swis. Can now call those swis and it will open templates. Right, so we can push that, and what will happen then is it will go and rebuild all of the status, and if I give it a moment or two and then reload this page, in theory these will get ticked. There we go, ticked. Excellent. Yeah, so it's quite nice that we've actually got those being done. So next thing, what was I about to say? Oh yeah, I was going to test it. So do I have /external/ports? Do I have PIC-OC in here? I don't. All right, let's go and quickly do that. So I don't have a working BBC Basic to do this testing, but a little while back I built PIC-OC. So cd:/external/PIC-OC is there. Except it's not that one. I want the version that's in GitLab. That's the one. So this is PIC-OC is a very small C interpreter, and there are various. Oh, I'm not signed in. All right, let's go just to Gerph/PIC-OC. There we are. This is my port of it. So if I just copy that, C ports, git clone this. CD riscar. Check out riscos. CD riscos ammo build 64. So this will take a moment or two because there's quite a few files in it. I think it's adding that -01 that's really slowed down the 64-bit builds. I don't think it's anything else. I may make the default not use 01. It's not a big deal. It's just it's a little bit more frustrating when you're waiting for things to build and you want stuff to work. So why is this useful? Because I've implemented swi calls inside PIC-OC. And if I've done it right, we should be able to use this as a demonstration platform. In fact, I may even put it into the environment and it will make it a lot more useful to use. But for now, it kind of does some really nice things. Once it's built, I'll show you. This is, of course, assuming that it's actually going to work, which you never know. I ported PIC-OC in about, was it an hour and a half or something? And got a really, really rudimentary SWI processor in there. Not processor, dispatcher. And then demoed it to people and then went to bed. It was stupidly late and I really should have just gone to bed. pyrodev minus common minus 64 GOS. Come on. AF64 dot PicOC. Right, this is PicOC. We can put it into interactive mode, and in interactive mode you can do things like this, and it just works, which is really cool. It's genuinely quite neat. So if we now copy this from here, so that directory into the Wimp templates, copy that AF64 PicOC, comma here, right? Now, here's the one where we ran the tool. If instead of that we do load module RM64 Wimp templates. Oh, I moved it. Bother. Let me just rebuild it. Minus F, make file module, that's it. Thank you. Right, and then we do GOS. And if I've done this right, we'll get the Wimp templates module started. And then we can run PicOC here, in interactive mode. Under suswix, OXC1234, because that was the SWI number that we allocated to open templates. And then we want to use some input registers, and I want to take register 1, so I want 1 shift left 1. I haven't implemented the macros yet or anything, so don't worry about that. And then the template file we want is testdata.templates.info. Is this going to work? Flags not supported. At argument, at moment, it should say, oh no, that's not right. 1 shifted left 1. Underscore flags not supported. Did I screw up the implementation? Entirely possible. Hello, come over here, please. Platform we want. See, library Riscos. Output register 10 or return 10. That's odd. Should be working. Oh dear. I mean, if it doesn't work, then it doesn't work, but because this isn't the flags that I'm actually processing at the moment. It should have been just fine. In fact, if I just go do that copy command again. In fact, what would be better would be ln-f, symbol at link force. There we go. Now every time I update it, it will be up to date. And then foreground. Run it again. Flags not supported. I must have got that code wrong. Right, well, in which case then, we'll just make that code not do anything. And I will debug it afterwards, obviously. Back over here. Oh, exit PicOC, re-enter PicOC. There we go. I have now called a SWI call on 64-bit operating system using PicOC, and seen that the code that I was using is working. It gives me much more confidence that my 64-bit implementation is working properly, and I feel very happy about that. So I hope that made some sense. I don't know why the code's broken. It's possible that there's something, maybe 1 shift left 1 doesn't work. I don't know. 1 shift left 1 equals %I. Surely not. That can't be wrong, can it? No, that's true. That's exactly right. So I must have done something stupid in there. But right now, yeah, this looks like we've got... Oh, that's why. This should be flags and... I should actually be checking whether they're set, not what the value is, because they're constants. Ah dear. Yeah, so there we go. That was what was wrong. I could see it as I was talking about it. Right, anyway. All that aside, let's go through what we've achieved today and what we're going to do next week. So so today, yeah, we've faffed around with that. We've provided a yeah, we provided a very rudimentary skeleton for building the Wimp Templates system. I've showed a little bit of the Pyromaniac code that handles the loading that we will be converting. We've basically just done open file and then close file. There's no load template in there yet, but that's largely mechanical, and we'll show that next week, I think. The implementation here is pretty simple. There's nothing particularly complicated about it. Where, as you can see here, the actual implementation in templates, there's some very simple code to read words, to read some data, open the file, check some things, allocate some memory, return. Nothing complicated. There's also no error handling, so we're a little bit out on that. We'll need to do that later. But we've got it linked. We're doing multiple. We're able to handle multiple of them. We've got some automated builds. So the automated build here will go and archive up the built version of the module and the executable, and it runs the very rudimentary test. The Riscos build here, you can see it actually goes and checks that it runs, and then it runs the module. But we don't actually load the module, we only go and build it. Maybe we should load it as well. That would be a good test. And then at the end of that, we then go and archive it all up. We've built a module that has some dummy SWI calls that will do the right thing. And that's it. Not a lot else. There's also been a lot of talking and explaining how we're planning to do this. Largely so that people get an idea of what's going on and where we're intending to go with this. I hope that was useful to people. If it wasn't useful, then please feel free to leave me a note. Drop me an email, gerph@gerph.org. I'm always available at gerph.org. And the links that are on the Riscos Open forums are where I'll post the updates and what's been done and explain things for people. I know there was a lot of chatter today that was a little unrelated to this project, but that's not a problem. I'm happy to talk about things. If people would prefer to watch me just code and just talk about the code, then I really want to do that, but I also want to make sure that people that are talking that are here are happy and that are enjoying it. I'm not going to pander to people if they want me to talk about what's going on in politics or what they thought of the latest soap operas or whatever, because I don't care about that stuff. Well, not on here anyway. But otherwise, I am happy to talk about things. But just accept that's the way that these sort of sessions go. Next week, we will attack the actual processing of the files. So we've processed the header here. We've processed the index. we found the terminator. Next bit will be start processing the data in the files that contains the window definitions. Oops, I've jumped to the implementation there. And that's going to tell us a lot more about it. There's also processing of things like the font data that can come later. But we're going to start processing window definitions. That'll take a little while to do as well. All right, I think I've wittered quite enough now. Hope you've enjoyed it. Sorry it's overrun by 20 minutes again, but yeah, that's the way it goes. Just try and enjoy it anyway. Thank you very much for your time, and I will see you all next week. And apparently it's got dark in here and I'm sitting in shadow again. Sorry about that. See you later. Bye.